For class, we are going to run through this review for the last three sections, 6.4 to 6.6. All right, first example, it says write the augmented matrix as a system of linear equations. Let the variables x, y, and z represent. Okay, so we are going to go, and again, these just go in order, so it's going to be 1x plus 3y minus 1z equals 5. And then we have a 0 to start off this row, so then that's 0x, we don't have to write that. 1y, so it's y minus z equals 3. In the bottom row we have two zeros, so that's 0x and 0y, so we just have z equals 0. And there's our system of equations that is representing this augmented matrix. And for part B it says to solve that system. So when we solve this system, we see that we have, this was in, we call it row echelon form. And the bottom row gives us one of the solutions. So now we just have to use backward substitution. So we're going to take z equals 0, we're going to plug that into this middle equation. And so that's going to give me y minus 0 equals 3. So that just tells me that y equals 3. So now I can substitute both of these values, y equals 3 and z equals 0, into the top equation. And then I should be able to solve for x. So that'll give me x plus 3 times, so I'm going up here, x plus 3 times y. I found y to be 3, so that's 3 times 3. And then z was 0, so minus 0 equals 5. So that's x plus 9 equals 5. So x equals negative 4. Now I have solved that system. So usually you write these as an ordered triple, so that would go negative 4, comma, 3, comma, 0. So there's our ordered triple. Okay. All right, so number 2 is asking us to perform some row operations. And so it's asking us to get this new row 3, we're going to take the previous row 3 plus twice row 2. So let's do some mental arithmetic here. So that's going to be 0 plus 2 times 0. That's still 0. Next one, we got negative 2 plus 2 times 1. So that's going to be negative 2 plus 2. So that gives us 0 there. And for here, I'm going to do 0 plus 2 times negative 2. So that's 0 plus negative 4. So that's negative 4. And finally, it's going to be negative 4 plus 2 times 0. So that's negative 4 plus 0. Still negative 4. So that's my new row 3, doing row 3 plus twice row 2 from the previous matrix. Okay, I did work some of these out just to save a little time. So here it's asking us to compute, and I think this was pretty much from the notes, compute this element, which is element in matrix A, row 3, column 1, times the element that's in matrix B in row 1, column 3. So 3, 1 in A, row 3, column 1 would be 4, and it'll be right here. And row 1, column 3 would be the 7, which is right here. So multiplying those, you get 28. And then in the next one, A, 3, 2, row 3, column 2. So that would be that 2. And then in matrix B, row 2, column 3 would be that negative 2. So we're multiplying those. And then adding them, we should get 24. Okay, for these ones we have like some scalar multiplications and then either adding, well, it looks like we're subtracting both. So it's not difficult, just try to, it's not difficult to do it, but it is fairly easy to make a quick mistake if you're going through it and not being real careful. So we have to distribute the 2 through D. So that's what I'm doing here. So that's negative 2, negative 6, 18, negative 14, 2, and 16. So that's what I've got right there. And then we're going to distribute a 3 through C, which gives me 3, negative 3, 0, 21, negative 12, 6. So that's what I've got here. And now I'm subtracting. All right, negative 2 minus 3. So negative 5 for the first element. Negative 6 minus negative 3, which means negative 6 plus 3, negative 3. 18 minus 0 is 18. Negative 14 minus 21 is negative 35. 2 minus negative 12 would be 2 plus 12, which would be 14. And then 16 minus 6 is going to be 10. So there's my solution to this operation here, 2D minus 3C. And for part B, I'm taking C minus 2B, and what happens here, I wrote out C and I doubled everything in B, but the dimensions are not equal. You have a 3 by 2 minus a 2 by 2. This is not possible, or it might say undefined. Okay, if to do addition or subtraction, we have to have the exact same dimensions in order to do that. Each element has to match up perfectly. Okay, with multiplication, however, we don't have to have the exact same dimensions, but what we do need to have are the inner dimensions the same, and the order does matter. So if we're doing C times A, C is a 3 by 2, A is a 2 by 2. 3 by 2 multiplied by 2 by 2. The 2's in the inner part here are equal, and we should get a 3 by 2 as our product. Okay, so we can do it because the 2's are the same in the middle, and we'll get a 3 by 2. Remember, when you're doing matrix multiplication, you're matching the row with the column. Okay, so I'm going to take this row multiplied by this column, so that's 1 times 4 plus negative 3 times 1, and I've got that written out here, 1 times 4 plus negative 3, or negative 1 times 3, sorry, negative 1 times 3. And then I'm going to take this row times the second column to get this next element, so that's 1 times negative 2 plus negative 1 times 5, so 1 times negative 2 plus negative 1 times 5 right there. Now I drop down to the next row and follow that same process. 0 times 4 plus 7 times 3 right there. And then I'm going to take row times this column, 0 times negative 2 plus 7 times 5. 0 times negative 2 plus 7 times 5. And then finally drop down to the bottom row, multiply that times each of the two columns. So that's negative 4 times 4 plus 2 times 3. Negative 4 times 4 plus 2 times 3. And finally, bottom row times last column, negative 4 times negative 2 plus 2 times 5. Negative 4 times negative 2 plus 2 times 5. Okay, so then I'm just going to do all of that arithmetic. So that's 4 plus negative 3, 1, negative 2 plus negative 5 is negative 7, 0 plus 21 is 21, 0 plus 35 is 35, negative 16 plus 6 is negative 10, and then positive 8 plus 10 is 18. So there's my product. Okay. And, okay, example, I guess I don't have it numbered here, but it's asking us to determine if A is the inverse of B. Okay, so remember we talked about matrices that were inverses. That means that when you multiply them, you get the identity matrix. So we're just going to go through that multiplication process again, like what we had just done. 1 times 9 plus 4 times negative 2, and then I'm going to go this row, this column, so 1 times negative 4 and 4 times 1 right here. Then I've got 2 times 9 and 9 times negative 2 right there. In the bottom row and last column, 2 times negative 4 and 9 times 1. And so that's negative 8 plus 9 right there. And it does turn out that I get 1, 0, 0, 1, which is our identity matrix, right? So when you see 1's in the main diagonal and 0's in the other positions, that is the identity matrix. So the answer to this question is yes. A is the inverse of B. Okay. So you have to multiply them out, see if you get the identity matrix. If so, then yes, we do have an inverse. And last question here, it says to represent this system in the form of a matrix. And so we're going to do our coefficient matrix: 2, 3, negative 4, 3, negative 5, 2, 7, 2, negative 1, taking all the coefficients. And we're going to multiply it by the variable matrix x, y, z as our column right there. And then that's going to equal our constants, 2, 3, and 1. Okay, and that's just representing it in this form. And I think that's all it's asking us to do. I think in the homework then what we had done and what we had showed was to multiply by the inverse of this matrix, and if you multiply the inverse times this matrix over here, then you end up with the solution, because if you multiply by an inverse on both sides, you solve for x. But I think on the quiz, I'm just having you set it up. Okay, so that is it. That's the